Welcome to lecture series on design of machine elements, unit 3 power screw. ये सेकंड इस लेक्चर सीरीज का सेकंड प्रॉब्लम है नवंबर दिसंबर 2024 क्वेश्चन पेपर में से क्वेश्चन 2 भी है। प्रॉब्लम इस तरह से, नॉमिनल डायमीटर ऑफ ट्रिपल थ्रेडेड स्क्वायर स्क्रू इज 50 mm। स्क्वायर थ्रेडेड स्क्रू है और ट्रिपल स्टार्ट है। इन ट्रिपल स्टार्ट स्क्रू L इज इक्वल टू 3 टाइम्स ऑफ पिच, 3 टाइम्स ऑफ पिच, and the nominal diameter is given 50 mm and the pitch is given 8 mm. It is used with a collar having outer diameter 100 mm and inner diameter 65 mm. कॉलर का आउटर डायमीटर है 100 mm और इनर डायमीटर है 65 mm. द कोएफिशिएंट ऑफ फ्रिक्शन एट द थ्रेड सरफेस एंड एज वेल एज एट द कॉलर सरफेस इज टेकन एज 0.15. म्यू इज इक्वल टू म्यू सी, दैट इज इक्वल टू 0.15 दिया है प्रॉब्लम में। स्क्रू इज यूज्ड टू रेज अ लोड ऑफ 15 किलोन्यूटन। इतना लोड रेज करना है यूजिंग यूनिफॉर्म वियर थ्योरी फॉर कॉलर फ्रिक्शन। Calculate the torque required to raise the load. Second, torque required to lower the load. And third, force required to raise the load if applied at a radius of 500 mm. ये 12 मार्क्स का ये प्रॉब्लम था इस क्वेश्चन पेपर में, नवंबर दिसंबर 2024 के क्वेश्चन पेपर में। तो यहाँ पे हम पहले गिवन डेटा लिखेंगे। एज इट इज अ ट्रिपल स्टार्ट स्क्रू, एज इट इज अ ट्रिपल स्टार्ट स्क्रू, द L, that is lead is equal to N into P. N is number of starts are 3. So number of starts are 3 and pitch is 8 mm. So lead is equal to N into P. So that is equal to 24 mm. 24 mm. And pitch is given 8 mm. Pitch is given 8 mm in this problem. The nominal diameter is D. D is the nominal diameter and that is equal to 50 mm. Nominal diameter of the screw is 50 mm. And the load to be raised. Load to be raised in this problem. Load to be raised is equal to W is equal to 15 kilonewton. W is equal to 15 kilonewton, that is 15,000 newton. Then collar outer diameter, collar outer diameter OD, DO is equal to 100 mm. DO is equal to 100 mm. So collar outer radius is equal to 50 mm, half of the diameter. Similarly, collar ID, DI is equal to 65 mm. So RI is equal to 32.5 mm. 32.5 mm. Coefficient of friction for the thread and collar is same. So mu is equal to mu c. Mu is equal to mu c and that is equal to 0.15. So this is coefficient of friction for thread. Coefficient of friction for thread and collar. Coefficient of friction for thread and collar is same in this problem, that is 1.15. Mu is equal to mu c and that is equal to 0.15. So in the step 1 we have to calculate the various thread parameters. So very first step in this problem is to calculate thread parameters. में इस प्रॉब्लम में क्या फाइंड आउट करना है? टॉर्क रिक्वायर्ड टू रेज द लोड, टॉर्क रिक्वायर्ड टू लोअर द लोड, फोर्स रिक्वायर्ड टू रेज द लोड इफ अप्लाइड एट अ रेडियस ऑफ 500 mm. ये तीन आंसर फाइंड आउट करने। तो पहले स्टेप में हम क्या करेंगे, सभी थ्रेड पैरामीटर हम कैलकुलेट करेंगे। तो लीड हमने कैलकुलेट कर दिया। लीड L इज इक्वल टू 3 टाइम्स ऑफ अ पिच, सो इट इज 3 into 8 दैट इज 24। हमने इनिशियल में ही ये कैलकुलेट किया। लीड ऑफ द स्क्रू हमने कैलकुलेट कर दिया 24 mm. Then we have to calculate the mean diameter. So mean diameter of the screw, that is DM. Mean diameter of the screw is calculated as nominal diameter minus pitch by 2. Nominal diameter is given in the problem 50 mm. 50 minus 8 mm is the pitch, so 8 by 2. 50 minus 4 is a 46 mm is the mean diameter of the screw for this problem. Therefore mean radius of the screw is dm by 2, that is 46 by 2, that is 23 mm. Then we have to calculate helix angle or lead angle. It is lambda. So tan of lambda is equal to lead L divided by pi into dm. So tan of lambda is equal to lead है, lead is 24 mm divided by pi into dm is 46. So tan of lambda का वैल्यू आया, tan of lambda वैल्यू 0.1661. Suppose this is equation 1, as equation 1. Then we have to calculate the, as per uniform wear theory, mean radius of the collar. As per uniform wear theory, यहाँ प्रॉब्लम में हमें यूनिफॉर्म वियर थ्योरी यूज करने के लिए बोला है. तो इस थ्योरी के हिसाब से मीन रेडियस ऑफ द कॉलर इज गिवन एज, मीन रेडियस का फॉर्मूला है, मीन रेडियस ऑफ द कॉलर इज गिवन बाय RM and that is equal to RO plus RI divided by 2. RO plus RI divided by 2. RO है, यहाँ पे हमने RO कैलकुलेट किया था, 50 mm is the RO and RI is 32.5. So 50 plus 32.5 divided by 2 is the mean radius of this collar, and that is equal to 41.25 mm. 41.25 mm. फिर हमें कैलकुलेट करना है कॉलर फ्रिक्शन टॉर्क रिक्वायर्ड टू ओवरकम द कॉलर फ्रिक्शन, और इसको हम सिंपली बोलेंगे कॉलर फ्रिक्शन टॉर्क. तो कॉलर फ्रिक्शन टॉर्क हमें कैलकुलेट करना है. इसका फॉर्मूला है TC इज इक्वल टू म्यू सी इंटू W इंटू RM. सो TC इज इक्वल टू म्यू सी दिया है हमें 0.15, W दिया है 15 किलोमीटर, दैट इज 15,000 न्यूटन, इंटू मीन रेडियस है 41.25. So we get this collar friction torque, and that torque is 92.81 into 10 to the power 3 Newton mm. ये collar friction torque equation 2 है हमारा, equation 2. Collar torque required at the threads to raise the load, that we will calculate first. So that torque is T1, and that is given by the formula W into tan of phi plus lambda into mean diameter by 2. This is the formula. So T1 is equal to W into tan of phi plus lambda. हम इस तरह से लिख सकते हैं, tan of phi plus tan of lambda upon 1 minus tan of phi into tan of lambda. इस तरह से लिख सकते हैं, multiplied by dm by 2. So this torque T1 is equal to W is 15,000 Newton multiplied by tan of phi is 0.15, mu is equal to tan of phi plus tan of lambda वैल्यू हमने कैलकुलेट किया था. tan of lambda वैल्यू कितना है 0.1661. tan of lambda is equal to 0.1661. ये हमने कैलकुलेट किया था 0.1661 divided by 1 minus 0.15 multiplied by 0.1661, and this whole multiplied by dm by 2. dm मीन डायमीटर लिया था 46 mm, तो 46 divided by 2 is 23. 46 divided by 2 is 23. So we get this torque required at the threads to raise the load W. So T1 हमारा 11,824 Newton mm. 1,11,824 is the torque T1, and this will mark as equation 3. So the total torque required to raise the load, W is calculated as total torque is T is equal to T1 plus TC. तो टोटल टॉर्क, इसको हम T रेज बोलेंगे, टोटल टॉर्क रिक्वायर्ड टू रेज द लोड. T रेज इज इक्वल टू torque required to overcome the thread friction is this equation 3. It is 1,11,824 plus collar friction torque we have calculated in the previous step. It is 92.81 into 10 raised to 3. 92.81 into 10 raised to 3. 92.81 into 10 to the power 3. So total torque required to raise the load is equal to 204.6365 into 10 to the power 3 Newton. This is our first required answer for this problem. Total torque required to raise the load in this problem is this. इतना torque है. Now we have to calculate the torque required to lower the load. Now we have to calculate torque required at the threads to lower the load. Torque required at the threads to lower the load. So T2 बोलेंगे. T2 is equal to W into tan of phi minus lambda into dm by 2. So this will be equals to T2 is equal to W into this is lambda minus 5. Okay. So W into bracket tan of lambda minus tan of phi upon 1 plus tan of lambda into tan of lambda to tan of phi. So whole multiplied by dm by 2. So T2 is equal to W is 15,000 Newton multiplied by tan of lambda is this value 0.1661 minus mu tan of phi is mu is 0.15 in this problem divided by 1 plus 0.1661 multiplied by 0.15 multiplied by dm is 46 divided by 2. So we get this torque. This torque comes out 5419 Newton MM. 5419 Newton MM. This is equation 4. Now this total torque required to lower the load. Total torque required to lower the load. Is nothing but equal to T is equal to T lower is equal to T2 plus torque required to overcome the collar friction. So T lower is equal to T2 is this 5419 plus collar friction torque हमने calculate किया है 92.81 into 10 to the power 3. So we get this total torque required to lower the load is equal to 98.23 into 10 to the power 3 Newton MM. ये दूसरा आंसर है इस प्रॉब्लम का. टोटल टॉर्क रिक्वायर्ड टू लोअर द लोड इज दिस. सेकंड आंसर है टोटल टॉर्क रिक्वायर्ड टू लोअर द लोड is equal to 98.23 into 10 raised to 3. Now last answer that we have to calculate. Three answers we have to calculate. Total torque required to raise the load, total torque required to lower the load, and force required to raise the load at a radius of 500 mm. So last answer is force required to raise the load at a radius of 500 mm. And that force is F. So the T raise is equal to force into radius. T raise is equal to force into radius. Force F into radius R. Therefore T raise आया था हमारा 204.6365. T raise आया था 204.6365 into 10 to the power 3 is equal to force F into radius is 500. So we get this answer. F is equal to 40 409.27 Newton. So this is third answer for this problem. Third answer. Force required to raise the load at a radius of 500 mm is this 409.27 Newton. इस तरह से ये सेकेंड प्रॉब्लम हमने कंप्लीट कर लिया. सो थैंक यू वेरी मच. सी यू इन द नेक्स्ट लेक्चर ऑन अनदर इंपॉर्टेंट प्रॉब्लम ऑन PYQ. थैंक यू.